Good evening, everyone. Let's continue with the last video of probability. Let's see a few more questions to brush up on the topic and see a variety of questions. We know what is the definition of probability. As we discussed, we know probability of any event is number of desired outcomes upon the total number of outcomes, right? Number of outcomes that we desire for or we are looking for out of the total number of outcomes that are created in the sample space. Right? Let's look at the question. The question reads, you might have read the question by now. Question reads, a month is selected at random in a year. So in a year, out of the year, a month is selected at random in a year, the probability that it is either March or October or January. How many months are there in a year? A year has 12 months. And we want to find a probability when it is either March. When we use the term either stands for or. Or means March will also do, October is also okay, and January is also okay. Means either March or October or January. All three can be in our favor. So what is the probability going to be? Probability of such an event is March, October, January. That is 3 months out of the 12. So that's 1 by 4. Now, the word over here is or. Okay. Or means this will also do, this will also do, this will also do. But instead of or, if we had an and, then what? Then this also has to be satisfied and this has to be satisfied. Okay. The two conditions have to be satisfied, only then we can consider. That is the condition for and, not or. For or means either of the three. Now, for example, if we look at later, we'll come across one more question where we'll see the use of or and. Okay, we'll emphasize on one more question which will have a question based on or and so on. Looking at the next question, we have, if a two-digit number is chosen at random, then the probability that the number chosen is a multiple of 4 is if a two-digit number. How many two-digit numbers are there? The first two-digit or the smallest two-digit number is smallest two-digit number, correct? 10. And the largest is 99. So total number of two-digit numbers will be 99 minus 10, but because we want to include 10, I'll add a 1 over here. So that is what? 90. Correct? Now again we can apply AP over here and we can find out the multiples of 4. If we are looking for multiples of 4, then we know after 10, then the next digit, right? Let's not write it here. We can write the statement elsewhere. Let's write it here. We'll say our set of numbers, a set of two-digit numbers will start with 10, 11, 12, 13, 14, 15, 16, 17, 97, 98, 99. So from here we can make out that the smallest two-digit number is 10, but the smallest two-digit number, which is a multiple of 4, is 12. Next, 16, and so on. And the last one would be, which is the last one? 96. Correct? 96. How did we get 96? We divided 99 by 4. 4 2s are 8. 4 4s are 16. So what we did? 99 minus 3. 3 is a remainder, right? That means this is extra. Or rather, if you want to go with it, then you can say, I'm sorry, then we can write 24 into 4, which is 96. Hence, 96 is the smallest one. Now, how many digits we have? How to find out how many two-digit numbers which are multiple of 4 we have? This is the first one. This is 4 threes are, and this is 4 into 24. So you can do 24 minus 3. But then we are including the multiple of 3. So plus 1. So that gives me 22. So what is the required probability? 22 upon 90. You can see, you can find out this part where we are saying, we are talking about the number of multiples of 2 by AP also. We'll write AN is equals to A plus N minus 1 times D. Your AN over here is 96, the biggest one. Your first term is 12 and your common difference is 4. When you simplify this, you're going to get 96 minus 12, that is 84. Multiplication will come down and become division by 4. N minus 1, that is 21 is N minus 1. So N is 22. This is also one way of finding the number of multiples of 4. Number of multiples of 4 between 4 between 10 and 99. Between 10 and 99. Right? So this is also one way of doing it. And this is also one way. Both ways, see, you got the answer as 22. So your probability is going to be 22 upon 99, which is 11 upon 22 upon 22 upon 90, which is 11 upon 45. I hope you have understood. Moving on to the next question. A number is selected randomly from 1 to 30. So total numbers 30, because we are going from 1 to 30. Probability that it is an even numbers. Yeah, sorry. Probability that it is a prime number. Which are the prime numbers between 1 to 30? 2. Can I write 1? No, because 1 is not a prime number, nor is it a composite number. It's a unique number. We know that. 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These are your prime numbers. So what is your probability? That's an easy one, but you have to just make a list of the prime numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 prime numbers out of the 30 numbers that are available. So the probability turns out to be 1 by 3. Right? Let's go on to the next one. Now I've already drawn the table for you. So just look at the question. It is completely opposite of what we had done in the previous video. uh, two dice are rolled simultaneously. When two dice are rolled, we know this is going to represent our outcomes, sample space. We can say this is our sample space. Probability that they show different ways. We know total outcomes, total number of outcomes is 36. 6 6 are 36. Outcomes with same face. How many outcomes have the same face? Outcomes with same face is nothing but the doublets, and there we know there are how many doublets? 1, 2, 3, 4, 5, and 6. So we have 6 doublets. Therefore, outcomes with different faces would be what? Their subtraction 30. So probability of, if I call this as my event E, then probability of E will be what? 30 out of 36, which is 6 5s are 30, 6 6 are 36. Right? Exactly opposite of what we had done in the previous video. There, instead of saying that the faces are same, the word used over there was doublet. If you remember, the word used was doublet. Here we are saying not a doublet. In other words, moving on to the last question of this video. A card is accidentally dropped from a pack of 52 cards. Probability that it is an ace card. How many suits are there? We have the spade, we have the club, and then in red we have the heart, and we have the spade. And each of them has one ace card. We have an ace card here, an ace card here, an ace, and ace. So we are dropping an ace card. We want to, we are finding the probability of getting an ace card. Ace, we have 4. And total outcomes, total number of cards in the pack, 52. So what is the probability going to be? 4 upon 52, which is 1 by 13. I hope you all have understood this. Children, I hope you all are doing the written practice of all the questions that have been discussed till now. And I hope everyone has understood. If there is anything, please mention in your comments. I shall re-repeat it, or I can take up questions that you all have doubts with. You can post it in the comments. I'll definitely take up in the next video. Thank you.